Our topic for today is laws of reflection.
Good job.
What happened to our light?
No idea.
I have an idea.
Really?
Consider this ray of light which strikes a mirror. This ray of light is called the incident ray. The point at which the incident ray strikes the mirror is called the point of incidence.
Let's go up.
Draw a line perpendicular to the mirror through the point of incidence. This line is called normal. The angle which the incident ray makes with the normal is called the angle of incidence.
It's still not working.
My idea is not over yet.
When the incident ray strikes the mirror, it will bounce off the mirror. The ray which bounces off is called the reflected ray. The angle which the reflected ray makes with the normal is called angle of reflection. Let us learn the two laws of reflection. The angle of incidence is always equal to the angle of reflection. If the angle of incidence is 30 degrees, then the angle of reflection will also be 30 degrees. Remember that these angles are always measured from the normal, not from the mirror. The incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane.
light dispersion and refraction through a prism. Have you ever noticed that diamonds sparkle in sunlight? Ever wondered why? They sparkle and seem to be giving out different colors. Just like oil spilt on any surface showcases different colors. The reason behind this phenomenon is the refraction of light. Before we understand what refraction is, let us conduct this easy and cool experiment of extracting a rainbow from white light. For this experiment, you'll need a prism, white light, and a dark room where the refraction can clearly be seen. Procedure: take the prism and keep it on the table. Ensure that the room is considerably dark for the light to be obvious. When light travels through the prism, it splits the white light into 7 colors. These are violet, indigo, blue, green, yellow, orange, and red. They appear in the same order, just like in the rainbow. Observe the light ray carefully inside the prism. Notice that the light ray bends at 2 different points. One when the light is entering the prism, and another when it leaves the prism. The question is, why is the light being dispersed into the rainbow colors? Explanation: prisms are made up of glass. The 7 different colors coming out of the prism constitute 7 different wavelengths. Each color represents a different wavelength of light. These different wavelengths travel at different speeds in the glass. This is the main reason for the formation of a rainbow or spectrum when the light travels through the prism. Another point to be noted here is that the angle of refraction is different for these colors as they have different wavelengths. When light touches the surface of the prism, refraction takes place at the boundary of the prism. In example, boundary between air and glass. Then the white light is separated into its component colors: red, orange, yellow, green, blue, indigo, violet. Refraction is the change in direction of a wave due to a change in its medium. When these wavelengths reach the other side of the prism at different angles, refraction takes place at the surface of the prism, i.e. at the boundary of the glass and the prism, and the angle of refraction is greater when they leave the prism. This separation of visible light into its different colors is known as dispersion. All these colors constitute the spectrum. The angle of refraction, which a light undergoes when it travels from one medium to another medium, is determined by the refractive index of a given medium. This is the reason why the diamond sparkles in broad daylight and makes it shiny.